Okay, in this video, we will talk about the slope formula. We've been talking about how to find slope from a graph. So if we've got a graph, you guys know to pick two great points, and then you count the rise, and then you count the run, and then you find their quotient, or set up a ratio or a fraction, right? So what happens when you're given two ordered pairs instead of a graph? Or a set of data instead of a graph. So the slope formula is M, that stands for slope. M is the slope. So M equals y2 minus y1 over x2 minus x1. Okay, so this y2 minus y1 piece gets you the difference in the two y coordinates, or the change in the two y coordinates. And x2 minus x1 gets us the change in our x coordinates. So just so we can have a little visual of this, if I've got these 2 points here and here, y2, I'll call this the second point, and I'll call this the first point. So y2 minus y1 is this number, that's y2, and then here's y1. So y2 minus y1 is just this difference right here. And the same thing for x2 minus x1. Here's x2 and here's x1. So this is the difference there. So what we've done is written an expression for what does the rise look like. This expression is the rise. And then what does the run look like? So the x2 minus x1 piece is the run. That's the rise, and then this piece here is the run. Yep, okay, so your notes are completely blank because we're just gonna get some good writing skills in. Notes can't always be written all the way for us, I suppose. We just wanted to get you guys some practice writing. And I'm actually going to pause the video so I can make sure I'm using the right examples that I'm going to use in class. The video is unpaused, yay. Okay, we'll call this box example number 1. And in example number 1, instead of being given a graph, we're going to be told that the 2 points on the graph are -2, 3, and +4, 8. Okay, and you guys probably see this and you're like, well, why can't I just get graph paper and graph it? And here's why. Let's go down to 1, 2, 3, 4. The third example. Let's write down example number 3 for now. Let's see, we've got the first ordered pair for example 3 will be 1/2, 3/5. The next one will be 5/2, 0. Okay, so when you guys look at fractions, you tend to get a little intimidated, and then you likely ask your teacher how you can put things on a graph with fractions. Furthermore, another reason that the slope formula is so incredibly helpful for us, don't write this example down, but maybe your numbers are like ginormous, 50,648 and 9.6 times 10 to the 8th. That's a ridiculously large number, and there's no way in the world you'd want to graph all of that. So instead of having to find a creative way to graph it or factor things out or count by halves or count by fifths, there's this slope formula that just kind of makes crunching all of our numbers a little bit easier. So back to our example number 1. So we want to find the slope, which is m. I'm going to say m equals, and then I know I have this fraction with all this y2, y1, x2, x1 stuff. So we talked about this in the beginning of the year. You can think of the y and the x as their first names, and because there's two separate y's, we've given them these little last names to help us differentiate which one is which. So what we're going to do, I guess we can label our ordered pairs, and if we label our ordered pairs, we'll know which number we're trying to call which. So if I call negative 2 x1, then I'm saying that this is my first ordered pair, which means the y value there, 3, has to be y from the first ordered pair. And the next ordered pair has 4 is the x from the second ordered pair, and 8 is the y from the second ordered pair. So now when I write y2 minus y1 over x2 minus x1, I'll know which numbers to call. Now you might notice I'm writing blank parentheses instead of the numbers that I see, and there's a method to my madness here. So go ahead and write little parentheses in place of all of those numbers, y2 and y1, and then x2 and x1. This is the blank for y2, and we've got y2 as 8. So in the bubble I'll put an 8. Then there's a minus sign from the formula, and then this bubble is in place of y1, and y1 we have as 3. So this is 8 minus 3 for the numerator. And then in the denominator, this bubble is in place of x2, and we said x2 was 4. And then this bubble is in place of x1, and this bubble is in place of x1, and x1 is negative 2. So I've made all of those parentheses, that way when we see minus and negative, we don't accidentally forget to have the minus sign that's naturally from the formula. Now we can just type this in on our calculator, and because we have those nice fancy calculators, we can literally type in this all as a fraction. So if you hit alpha, that's the green button, y equals, and enter, you can type it in that way. Another way is to open up Desmos and type it in on that. So we'll go to Desmos, the testing calculator. My internet's so slow. Okay, so we had a fraction, and in the numerator, we had 8 minus 3. We had 8 minus 3 in the numerator, and then in the denominator, we had 4 minus negative 2. We had 4 minus negative 2. So what we've got back now is this fraction, 0.83333333, or we've got this decimal. We typically like slope to be written as a fraction because the fraction means something in slope. It helps us visualize what the graph is actually going to look like. So by clicking that button over here with the little fraction bar, you can toggle between the decimal and fraction equivalent. So this is 5 over 6 as the fraction. So the slope in our example 1 is positive 5 over 6. This tells me that on the graph, anytime we go from one point to the next, we're going up 5 times and then over 6 times. Up 5 times and over 6 times. Whoops, I was trying to erase that. Try to erase it again. There we go. Okay, looking at a second example, we've got 7, negative 6 as one ordered pair, and negative 5, 2 as another ordered pair. Okay, and we know that the slope formula is that m, or the slope, equals y2 minus y1. So I'll put a bubble in place of y2, minus sign from the formula, and then a bubble in place of y1, all over x2 minus x1. And again, I'll have a open set of parentheses for x2 minus the open set of parentheses for x1. Okay, now I'm ready to go fill in the numbers after I label my ordered pairs, of course. So I'll label this ordered pair as this is x1, and that means that negative 6 is y1. Negative 5 is the x value in the second ordered pair, so negative 5 is x2, and this positive 2 is the y value in the second ordered pair, so 2 is y2. Now this first bubble is in place of y2, and y2 we said was 2. The second bubble in the numerator is in place of y1, and y1 is negative 6. Okay, and then x2 is this first bubble, x2, and we said x2 was negative 5. Okay, and then the last bubble in the denominator, the second one in the denominator, is x1. x1 we said is 7. So I'm going to split my screen by clicking the Windows button and one of the arrow keys. Okay, and now I can see both of my screens at one time, or both of my pages at one time. So we've got the numerator. Oh, I'm going to click the, I guess I can show you guys how I've done that. By hitting the divide key, we get a fraction up on our keyboard because fractions just mean to divide. In the numerator, I'm going to type in 2 minus negative 6. And then in the denominator, I'm going to type in negative 5 minus 7. And again, I've got this decimal. This looks to be a repeating decimal, so I could say it's rational. Another way to know it's rational is we can express negative 0.6666666 and so on repeating as negative 2/3. So since I can write it like a fraction, I know it's rational. So that means that m, the slope, is negative 2/3. So I already know some things about this graph now. I know that it's going to go down, and it'll go down 2 times and then right 3 times. So it goes side to side more than it goes up and down, which means it's kind of flat. So it's not incredibly fun to ride my bike down, but it's still pretty fun because it gets to go down. And number 1, that was going uphill, so it wouldn't be very fun to ride my bike down. Okay, looking at the example we had with the fractions, again, we're just going to set up the formula. We know that m is supposed to equal y2 minus y1. Where's the... Okay. M is supposed to be, m equals the difference in the two y values, so y2 minus y1, over the difference in the two x values, so x2 minus x1. Okay. So I'm going to rewrite that now with bubbles in place of all of the letters. This bubble is in place of y2, and I guess I haven't labeled my ordered pairs yet, so I'll go back and do that. I'll call 1/2 x1 is the x value from the first ordered pair, which means 3/5 is the y value from that first ordered pair, so 3/5 is y1. 5/2 is the x value from the second ordered pair, so 5/2 is x2, and 0 is the y value from the second ordered pair, so 0 is y2. Okay. This first bubble in the numerator is in place of y2 from the formula, so I'm going to take the value for y2, which is 0, and put it in that bubble. And then the second bubble in the numerator is in place of y1 from the formula. So the value for y1 we have is 3/5. So 3/5 will go in that bubble. Okay. Now we've got x2 minus x1 in the denominator. So this first bubble is in place of x2, and x2's value is 5/2. Okay, and then for x1, that's the last bubble in the denominator. The set of parentheses is in place of x1, and the value for x1 is 1/2. Okay, so now I'm ready to type this in on my calculator. We've got, I'm going to hit the fraction bar, or the division key, and that gives me the fraction bar. In the numerator, we have 0, oops, close parentheses, minus, we have another fraction in the numerator, so I'm going to click the divide key again, and we can see another fraction pops up, 3/5. Okay, now we go down to the denominator, and in the denominator we have a fraction minus a fraction, so I'm going to click the division button again, and I've got 5/2, and then minus the other fraction, 1/2. Okay, that's equal to -0.3. That's a terminating decimal, and we know terminating decimals are rational. We also know rational numbers can be expressed like a fraction. If I click on that fraction key, it'll toggle -0.3 to -3/10. So what that tells me is this slope is -3/10. That seems to be a lot flatter than the other one that we just did. It's going up and down 3 times, but then over all the way 10 times. So that's really, really flat. What am I looking for? Eraser. Okay. We'll do another example here. We will add the example in. We've got, this is example 4. And 2 ordered pairs we'll be working with. Here we want to find the slope between the ordered pair 2 and 2, 3/4. And then the next ordered pair is 9/4, 3/4. Okay. So we want to find the slope between those 2 points. So we've got our slope formula coming in clutch. We know that the slope formula is y2 minus y1 all over x2 minus x1. So y2 minus y1 all over x2 minus x1. Okay. And I'm going to set up my blank parentheses. This first set of parentheses in the numerator is in place of y2. So I need the y value from the second ordered pair. So 2 is the x value from the first ordered pair. 2 is the x value from the first ordered pair. 3/4 is the y value from the first ordered pair. So 2 is x1 and 3/4 is y1. 9/4 is x2 because it's the x value from the second ordered pair, and 3/4 is y2 because it's the y value from the second ordered pair. Now going back to the formula, we've got this first parentheses is in place of y2, and y2 is 3/4. So we've got 3/4 minus, just a natural minus from the formula, and then this bubble is in place of y1, so the y value from the first ordered pair is 3/4. And then the denominator, this bubble is in place of x2, and we've got x2's value is 9/4. Minus sign from the formula, and then the next set of parentheses is for x1, and we're saying x1 is 2. So now we just type this in on our calculator. I'm going to use Desmos because I don't have the TI-84 app on my computer. Okay, so we've got, we're going to type in the fraction bar, the division sign, and the numerator has 3/4 minus 3/4. And then the denominator has 9/4 minus 2. That's 0. And that makes sense because our numerator was a number minus itself. So those were opposites, right? A positive 3/4 and a minus 3/4 makes 0 because it's a 0 pair. And then whatever that is, right? Any number there, it's 1.25. But no, it's 0.25. Anyways, we've got 0 in the numerator, so this is 0 divided by any number. Of course, it has to equal 0. And now I know that this graph has it's a sideways horizontal line because 0 slopes are horizontal. Right, we've got the z matching up there, 0. And the z matches up on that line. Okay, we've got one more example that I want to do. And then in class I had you guys make your own using, hopefully using some dice. Get some sort of fun in there. Example 5. Example 5, we want 7.5, 3. 7.5, 3. And we want 7.5, 2 9/10. Okay, so we want to find the slope between those two ordered pairs. So we're looking for m, the slope. We know that m is the same as y2 minus y1 over x2 minus x1 over x2 minus x1. Okay, before I set up the fractions with all the parentheses this time, I am going to remember to label my ordered pairs. So this 7.53 is the first ordered pair. So 7.5 is x1 because it's the x value from the first ordered pair. 3 is y1 because it's the y value from the first ordered pair. 7.5 is also the x value in the second ordered pair, so 7.5 is x2. And then 2.9 is y2 because it's the y value from the second ordered pair. Okay. So we'll have our fraction bar. And then we've got our set of parentheses for y2, which is 2.9. So I'll put 2.9 minus the parentheses for y1, which is 3. And then we've got a set of parentheses for x2, which is 7.5, minus a set of parentheses for x1, which is also 7.5. Okay, so now we've got m equals, and now I can turn to my calculator if I need it. Even if you don't need it, please double check yourself on the calculator. Okay, we've got, we'll make our fraction bar. We've got 2.9 minus 3 in the numerator, and then 7.5 minus itself in the denominator. And that says undefined. So the slope here is undefined, which means it's a vertical line. And that makes a lot of sense because the u matches up with the vertical line, right? They even undefined. Okay, now why does that actually make sense with math? We've got the same x value in both of these ordered pairs. So that means going from one ordered pair to the next ordered pair, there is no run. There's no run. But there seems to be a rise of about 1/10, so a small rise maybe? But there's certainly no run. And if there's no run, then it's not going side to side at all, so it's only going up and down. That last example we did in class, you guys made your own, so I'm not going to put that in the video. Hopefully it keeps the video a little shorter. If you've got questions, comments, concerns, please don't hesitate to reach out to me. This video was on using the slope formula. OF